Now we look at example for subtopic 4.5. Two long straight parallel wire carry current in the same direction. Okay, this is the situation, and the question asks you to determine whether the forces on the wire are attractive or repulsive. And the second question, if the wire are 24 centimeter apart and carry currents of 2 ampere and 4 ampere respectively, find the force per unit length on each wire. Okay, we go one by one. For the first question, determine whether the forces on the wire are attractive or repulsive. So the key word here is the same direction. So we must identify the direction of current in both wire. Is it the same direction or opposite direction? So it's stated here that the current are in the same direction. So as we learned before this, if the current in both wire are in the same direction, that means the answer will be the both wire will attract each other. So the forces involved here are attractive force. Okay. So for the second question, if the wire are 24 centimeter apart and carry current of 2 ampere and 4 ampere respectively, so the question asks you to find the force per unit length on each of the wire. Okay, the force per unit length on each wire is actually the same. So we only have to calculate one using equation F over L. F over L equals mu naught I1, I2 over 2 pi R. Okay. Make sure before you calculate or you substitute the value, make sure all the value are in SI unit. So for exponent negative 2. So your final answer is 6.6667 times 10 to the power of negative 6. The unit is Newton per meter. Example 4.6. A rectangle coil of dimension 4.4 cm times 8.5 cm consists of 25 turns of wire and carries a current of 15 milliampere. A 0.35 Tesla magnetic field is applied parallel to the plane of the coil. Calculate the magnitude of the torque on the coil when the field makes an angle of 30 degrees with the plane of the coil. Okay. So the given information is 5.4 centimeter times 8.5 centimeter is actually will give you the information to calculate the cross-sectional area A. Okay, 0.054 times 0.085 already in SI unit. So the cross-sectional area of the rectangle coil is 4.59 exponent negative 3 meters squared. The question also given you the current flow in the coil, 15 milliampere. Milli is 10 to the power of negative 3. Okay. So the strength of the magnetic field 0.35 Tesla already in SI unit. The number of turns for the rectangle coil is 25 turns, the value of N, and the angle between the plane and the magnetic field is equals to 30 degrees. So the theta for the equation for torque actually is between the normal of the plane to the magnetic fields B. Okay, that's why we have to minus 90 degree minus with 30 degrees. So the theta that we want to substitute in the equation is actually 60 degrees. Using equation torque equal NIAB sine theta, you already have your N, the current, the cross-sectional area, and also the magnetic field strength. and the theta is 60 degree. Substitute in the equation, you will get your final answer is 5.2173 exponent negative 4 Newton meters. Example 4.7. In a mass spectrometer, the magnetic field and electric field for selecting the velocity of the ions are 0.56 Tesla and 1.20 exponent 5 volt per meter respectively. The diameter of the circular path for the oxygen ions are 14.12 cm, 15.04 cm and 15.90 cm respectively. The charge of each oxygen ions are 1.6 exponent negative 19 coulomb. Calculate the mass of each type of oxygen atoms. Okay. The question gives you the electric field strength 1.2 exponent negative 5 volt per meter and the magnetic field strength 0.56 Tesla. So this is B, this is E. And also the diameter of the circular path, 3 diameters, 14.12, 15.04 and also 15.9 centimeter. And the last one is the charge of oxygen ions is 1.6 exponent negative 19. So in this question, it involves two parts of the mass spectrometer. One is in the velocity selector and the other one is the evacuation chamber where the particles or the ions will deflected in circular path with a different diameters. Okay, so as we all know, the concept in mass spectrometer where the deflection of the circular path with bigger radius means the mass is also big. Okay, so if the radius is smaller, that means the mass of the ion is smaller. Because mass and the radius of the circular path is directly proportional. So now the question asks you to find each of the mass for each of the ion oxygen with different diameters. Okay, so first, in the velocity selector, we know the concept in velocity selector is the electric force is balanced with the magnetic force. That's why the particle will go in a straight line. So from the equation, Fe is equals to Fb. So we know QE is equals to QVB. Okay, so Q here we can cancel because it's the same charge of ions, oxygens. So we can cancel the Q. So simplify equation. So your velocity in the velocity selector is equals to E over B. Why the velocity is important? Because in the evacuation chamber, you have to use the velocity. Because once the oxygen ion pass through the velocity selector, the velocity is equals to E over B. So with the same velocity, the oxygen ion will enter the evacuation chamber and then deflected at a certain diameters. Okay, so first we have to calculate the velocity. Okay, substitute of the value of E and also the value of B. So you will get the velocity is 2.1429 exponent 5 meter per second. So this is the velocity that the oxygen ion will enter the evacuation chamber. Okay, then we go to the evacuation chamber. Here we only have one field, that is magnetic field. That's why once the oxygen ion enter this evacuation chamber, the oxygen ion will deflected in a circular path. Okay. So when the concept in the evacuation chamber, when the oxygen ion deflected in a circular path, that means the magnetic force is provided to the centripetal force. So FB, the equation is QVB. Centripetal force is equals to mv squared over r. Okay, so simplify the equation. Make your mass as your subject because m is what the question want you to calculate. So m equals to b qr over v. So in order to calculate the mass for each of the oxygen ion which deflected different diameter, we use the first equation that we have been derived just now. Okay. So for diameter 1, let's say 14.12 centimeter. Okay. The equation only have the radius. That means diameter 14.12 centimeter, you have to divide 2 to get the radius. Okay, so make sure your diameter must be in SI unit. So for the first mass of oxygen ion is 2.952 exponent negative 26 kilogram. For the next diameter, you will be using the same equation, only the diameter is different.